Hello everyone, in this video I would be showing you the development of the funnel. The development of pentagonal prism, hexagonal prism involved seaming, whereas the development of the truncated square based pyramid involved the process of shouldering. Here we would be doing shouldering in order to join two components. Funnel involves the frustum of a cone as well as a cylindrical part. So therefore, let us start by drawing the circle. That is, whenever you look the cone horizontally, from the horizontal point of view, cone always looks like a circle. Like two circles placed, one of larger diameter, the other of the shorter diameter, which serves to be the lower, that is the cylindrical part, that is the diameter of the cylindrical part. Okay, now let us start by drawing the circle. Before that, let us have an XY line. Okay, so X and Y, VP and HP shall be marked as well. Okay, now let us draw the circle by center point of diameter, or let us take the radius itself. They say that the cone should have the diameter of 80 mm. So the radius becomes 40 mm. Yeah. Let me move the circle a bit. And let us make it a visible line. Yes. So once we are done with it, now keeping the same center, let us draw one more circle of diameter 20 mm. Okay. Yes. Once we are done with it, now let us start with the drawing of the vertical position of the funnel. The funnel is having the cylinder at the bottom, which has got the height of 30 mm, and the overall height would be 90 mm. That is, the height of the frustum of the cone should be 60 mm. Okay, now let us draw a line from here to here, and let it be a projection line. Okay, again from this point, let us draw the projection line. Okay, from this point as well, and from this point as well. Fine. So once we are done with it, now let us start by drawing the cylinder. In the vertical plane, the cylinder looks like a rectangle. Okay, so the height is given to be 30 mm. So I would be drawing a 30 mm cross 30 mm, 30 mm cross 20 mm rectangle. Okay. Yes. So let us draw the center line from here till here. Okay. Now what we need to do is, let us look at the length, or what we can do is, we can just draw or else we'll just delete of this line and draw it in the form of sections, that is from here to here, okay, then up to here, then up to here, okay. Now let us know the dimension of this line. Okay, we want it to be 60, so I am extending it. Let me have it here. Yes, but it would again be problematic, so let me have it here. Fine. Now the diameter of this larger circle is 80 mm, that means the radius is 40 mm. So for that, what I can do is, that means the top circular cross section is of 40 mm radius. So from here I would be drawing the line of 40 mm, okay, and again from here I would be drawing a 40 mm line, okay, which I would be joining it here, and this I would be joining it to this point. Now let us use a projection line and draw the remaining part of this cone, okay, until, or we can extend this line until it intersects the center line, okay. Let us trim the excess line. Fine. Once we are done with it, now let us know the length of this line as well as from this point till this point. Okay, so that is 67.08 and 22.36. Okay, now let us start with the actual development. Development in this case is pretty simple, okay. So 67.08 plus 22.36 is roughly equal to 90 itself. So let me just, so this is the height of the funnel is 90, which involves 60 mm to be the height of the frustum of a cone and remaining 30 mm to be the height of the cylinder, okay. Let us check the diameter as well. Okay, yes. Now let us start by drawing the let us select the visible line itself. The length is given to be 90 mm, okay, 90 mm, and yes, up till here. Now one thing what we need to note here is, how do we know up to what distance or what should be the sweep of this particular arc? Now what we can do is, let us draw a reference line, okay. Let us draw a reference line from this point to this point and back till here, okay. Let us know the angle between them. Yeah, it says it is 151 degrees. Now what we need to do is, there is a formula for the calculation of the angle. The formula goes like this. Let me write it here, okay. So angle is equal to small r by capital R into 360. Now, what is small r is the radius of this larger cone. Okay, that is 40. That is radius of the base of this particular frustum of the cone. Okay, is 40 divided by, we have taken this particular length, that is from this point to this point. Okay, that is the lateral height of the frustum, lateral height of the cone is 90 mm, using which we have drawn this arc. Okay, divided by 90 and multiplied by 360. Okay, which would give us approximately 160, which would give us 160 degrees. Okay, so now let us draw. We want this angle to be of 60 degrees, of 160 degrees. So I'm changing it to 160. Okay, and let me extend this arc up till here. Let me verify whether the length is 90 or not. Yes, it is 90. Fine. Now, since we need the frustum of the cone, I need to cut the lower diameter. That is, I do not require a cone, I require the frustum of the cone. So therefore, I would be cutting the diameter of 20 mm. Why 20 mm? Because the diameter of the cylindrical part is 20 mm. Okay, again use the arc by center point. From here, 20 mm is the 20 mm is the radius from here till here. Okay, so this is the part which would be cut. Let me make it a visible line. Fine. Now, yes, so this is the region which would be cut in order to achieve the frustum of the cone. Now, since we are doing seaming for the frustum of the cone in order to join the two ends, let us mark that as well, which would be 5 mm. And from this point 5 mm as well. Okay. So let me delete this line and draw the 5 mm here as well. Okay. Fine. So this should be 5 mm. Yes. So this is 5 mm. These are the seaming allowances again. We would be doing seaming, for which we have left these two materials. Now once we are done with the frustum of the cone, let us look into the cylinder. Construction of the cylinder is very simple, before which we require the calculation part. Okay, so let me just move this a bit. Yes, so let me do the calculation here itself. This is with respect to the frustum of the cone. Okay, now let us make few calculations with respect to the cylinder. Okay, in the case of the cylinder, what happens is length, that is the circumference of the cylinder of radius 10 mm is 63 mm. That is, we get 62.8, which can be 63 mm. Okay, so the total length is equal to 63 mm plus the 5 mm allowance on either side, which would be 10 mm. That would give us 73 mm. Okay, fine. Now let us draw the rectangle. Okay, width. Let the width be 30 mm, cross height be 73 mm. Okay, so this is how the cylinder looks. Fine. Let me keep the cylinder here. Now what we need to do is, on either sides 5 mm need to be marked. Okay, 5 mm. And 5 mm here as well. Let us keep the sweep to be 20. Or let it be 60. Yes, this looks better. So once we are done with it, let me zoom this part. Yes. Now using the visible line. Okay. So now let us verify the dimensions of this. And let us fill this part. This is individually joined by seaming. That is, we would prepare the cylinder by using seaming first, and later we would be doing the process of soldering again in order to join the cylinder and the frustum of the cone. Okay, so this is how the cylinder part would look, and we have seen how the frustum of the cone looks. So that is all about the video. Thank you for watching the video. Hope you have liked the video. Don't forget to subscribe the channel so that you would be notified whenever I upload the videos in the future, and don't forget to like the video if you have liked it, and share it with your friends so that they would gain the knowledge, channel gains its popularity. Thank you.